This is a brief quick start video to help you set up and use the UM9B BL-L power electric detector and APM analog power module. It can be very challenging. First, let's talk about the UM9B detector. It's a very sensitive, high voltage output analog power electric detector that is used with our APM analog power module. The APM powers the UM9B detector and provides the analog output. Notice that it includes a 2-inch light tube. This narrows the field of view and helps suppress EMI noise. Now let's check out the optical setup. The UM9B detector is mounted on a Delrin post and aligned to a low-power visible laser diode that we are modulating at 10 Hz as required. The probe is plugged into the APM power supply, and the analog output is connected to a digital scope on channel 1. I've set the oscilloscope up as follows. Range set to 2 volts. Channel 1 is DC coupled and set to a 1 megaohm input impedance. Time base set to 10 seconds. Trigger set to channel 1. If you're trying to measure at the sub-microwatt level, I strongly suggest you use an external trigger input on the oscilloscope. Okay, let's get started. I'll power up the APM and UM9B. There will be a large positive voltage output that will slowly settle back to several hundred millivolts. It can take several minutes to reach thermal equilibrium depending on your lab environment. Now, in preparation to measure the power, I've added a quartz window to the UM9B. I've set the scope voltage range to 200 millivolts and time base to 50 milliseconds. I'll turn on the modulated laser and we immediately see the voltage output of the probe in response. I'll use a cursor feature on the scope to measure the detector sawtooth voltage from the base to the peak. It measures 656 millivolts. Now, to calculate the laser power, you divide 656 millivolts by the voltage responsivity of the UM9B, which is 39 kilovolts per watt, and that equals 16.8 microwatts. If we correct this for the window loss of 8%, we'll get a laser power of 18.3 microwatts. That's how you use a UM9B and APM to measure a chopped or modulated laser. Now let's consider using the UM9B without a transmissive window. I've removed the quartz window from the probe. I've set the scope range to 500 millivolts per division. As you can see, the voltage baseline is not stable. Why? It is because air currents in this lab have the effect of changing the detector's temperature, which results in generating a voltage. In addition, the windowless probe will now respond to thermal background in the lab. This includes response to the black body radiation from your hands, arms, or torso, as you can see in this video. Caution: if you can't set the UM9B up in a closed environment with no air currents or background thermal radiation, you must use some type of optical window or filter. If you have questions about the UM9B BL detector, please call us at 503-697-1870 or send us an email at info@Gentec-EO.com.